My dear friends, we have the initial value problem with differential equation here and initial condition here. And when we look at our differential equation, we observe that it is a first order linear differential equation. Remember, the general form was y prime plus p of x times y is equal to q of x. And I can rewrite my equation so that it fits our general form. Y prime plus minus 1 times y is equal to 2 sine 3x. And you see minus 1 is equal to our p of x function. And when I integrate it, p of x dx, which is minus 1 dx, is equal to minus x. And I can now calculate our integrating factor, mu of x. The formula was e to the integral p of x dx, and the result is e to the minus x. And to use our integrating factor, I'm going to multiply our equation by integrating factor to obtain y prime e to the minus x plus minus 1 times e to the minus x y is equal to 2 times sine 3x e to the minus x. So here, remember, I always get d over dx y times mu of x, which is e to the minus x, and our right hand side is 2 times sine 3x e to the minus x. Let's check it. The derivative of the multiplication is the derivative of the first term, y prime, multiplied by the second, e to the minus x, and the derivative of the second term, which is minus 1 times e to the minus x, times the first term, y. So we are done. And next, I'm going to pass this d of x dx term to the right hand side and integrate both sides. So this integral and derivative undo each other. I obtain y times e to the minus x here and 2 times integral sine 3x e to the minus x dx to the right hand side. And I'm going to call this integral I. And to take this integral, I am going to apply integration by parts. You see, because it's a multiplication of a trigonometric function with an exponential function. So I is equal to integral of sine 3x times e to the minus x dx. And remember our keyword here, labte, so that we can decide which function to call u. And we have sine 3x, which is a trigonometric function, sine 3x, and also an exponential function, e to the minus x. And the former deserves to be called as u, and the latter is dv, e to the minus x dx. So I continuously differentiate u. Sine 3x has derivative 3 cosine 3x, and derivative again minus 9 sine 3x, and when I obtain sine 3x again, I stop and continuously take the integral of dv. E to the minus x integral is minus e to the minus x, and integral again minus make a plus e to the minus x. So this first cross has a sign plus, and this second cross has a sign minus, and I return back to the integration with a plus sign. So our integral appears to be the first cross plus e to the minus x, minus e to the minus x, plus minus makes a minus, sine 3x, and the second cross minus e to the minus x times 3 cosine 3x, and finally my integral minus 9 integral of sine 3x e to the minus x dx. And here, guess what? I have I again. and minus 9i passes to the other side with a plus sign, plus 9i, and another I again, another I here makes a 10i. 10i is equal to, let's take a minus e to the minus x parenthesis here, sine 3x plus 3 cosine 3x, right? And of course, a constant term. Let's call this constant term C1. And I obtained the formula for 10i. And I was going to search for a 2i. And let's divide both sides by 5. Divided by 5, divided by 5. And here I have 2i. But 2i is equal to y times e to the minus x. Here I have y times e to the minus x, and right hand side is minus e to the minus x divided by 5 sine 3x plus 3 cosine 3x, and let's call c1 over 5 as c. Finally, to find y, to leave y alone actually, I multiply both sides by e to the x. And e to the x, e to the minus x cancel out. Here I have 1. And I have here c times e to the plus x. Sorry, my minus x, did I say plus x? E to the plus x, e to the minus x cancel out each other. And here also e to the plus x, e to the minus x makes 1. And the multiplication results in c times e to the x here. So I finally have y is equal to minus 1/5 sine 3x plus 3 cosine 3x and plus c times e to the x. Now I can apply my initial condition. Y0 is equal to 1. Y0 is equal to 1 is equal to, and I'm going to plug in x is equal to 0, and sine 0 is 0, cosine 0 is 1, here I have 0, I have 1, and e to the 0 is also 1. So my final result is minus 3 over 5 plus c, and it follows that c is equal to minus 3 over 5 passes to the other side as 3 over 5. 1 plus 3 over 5 makes 8 over 5. And the final result is y is equal to, let's distribute this minus 1 over 5 inside the parentheses, so that I have minus sine 3x minus 3 cosine 3x divided by 5 and plus 8 over 5 e to the x. My dear friends, this is the result of this question.